In this video, we will use this function f of x equals x plus 6 divided by x squared plus 8x plus 12 to find the domain and any x and y intercepts. So first we'll find the domain. Remember that when you're finding the domain of a rational function, your focus is the denominator, because the denominator cannot be 0. So to find the domain, we take the denominator and we say it can't be 0. So we have x squared plus 8x plus 12, and we say that can't be 0. This is a quadratic equation. This quadratic equation can be factored. I need two numbers that will multiply to give me 12, that will add to give me 8, and those two numbers are 2 and 6. Since everything is positive, I would have x plus 6 times x plus 2 cannot equal 0. Just to do a quick check, last times last would give me 6 times 2, which is 12. First times first, of course, is x squared. And then outside times outside is 2x, plus inside times inside, which is 6x. And 2x plus 6x is 8x. So now that I have it factored, I can set each one of these not equal to 0. So x plus 6 cannot equal 0. Subtracting 6 from both sides will give me x cannot equal -6. Then I have x plus 2 cannot equal 0. Subtracting 2 from both sides will give me x cannot equal -2. So I'll need 3 intervals to describe this domain, because there's two numbers that x can't be, -6 and -2. So if I put open circles at -6 and -2, x can be everything to the left of -6. Excuse me. It can be everything in between -6 and -2, and it can be everything to the right of -2. So using interval notation, I have -infinity up to -6, union -6 to -2, union -2 to infinity. And that is the domain of this rational function. Now moving on, I need to find the x and y intercepts. So remember, to find the x-intercepts, we're going to let y equal 0. Now remember, I can set the whole function equal to 0 like this. But then in the next step, to solve for this, you're going to multiply by the denominator. And on the left, the numerator will cancel out with the denominator, and you'll just be left with x plus 6. And on the right, 0 times anything is just 0. So you really can start out by finding the x-intercepts of a rational function by just setting the numerator equal to 0. Because if you think about it, a fraction is equal to 0 when its numerator is equal to 0. So this is going to give me, if I subtract 6 from both sides, x is equal to -6. However, that sounds a little familiar. You always want to check your x-intercepts against the domain. And if I look, -6 is one of the values that x can't be. Because if I use -6 in the numerator and the denominator, it's going to give me 0 in the denominator. And 0 over 0 is undefined. So since that was the only 0 of the numerator, we say this function has no x-intercepts. Finally, to find the y-intercepts, we're going to let x equal 0. That means I'm going to find f of 0, which would give me 0 plus 6 over 0 squared plus 8 times 0 plus 12. Well, anything with an x in it is going to go away, so that's just going to be 6 over 12, or 1/2. So the x-intercept is 0. I'm sorry, the y-intercept is 0, 1/2.